mean more, right? It's like I have at least $2 doesn't mean I have like $1 million, right? So let's just color this red, right, Luke? You keep shaking your head. Let's color this one red.
No.
Why don't we just keep it white?
Leave it white?
Yeah.
Oh, that's interesting. Sure, let's call the third color white. So let's leave it white, Ari says. Well, I don't know, why can't I color this one red? Jillian?
Because in rule number 2 it says it has to be all one color or 3 colors.
Right, so if I started coloring this one red, if you look at this crossing, here's a blue guy, a red guy, and a red guy, and that's 2 colors appearing on a crossing, not 3. So let's leave it white, I guess, or color it white. Now are the conditions satisfied? Well, certainly the first one is really easy to check, but to get the second one, you have to check each crossing. Are 3 colors appearing here? I guess red.
Yes.
I didn't intend to be so patriotic, but red, white, and blue here.
No.
So here's red, white, and blue, and here's red, white, and blue. I picked those colors for clarity to see on the board, but often they're like red, blue, green, right? The chalkboards. But anyways, unintended patriotism. I have nothing against pride for country and stuff. But anyways. Alright, so here's a related thing. Can we find another, this is one tri-coloring. Is there another tri-coloring? Another one of the same picture. Is there another tri-coloring of the same picture? Luke?
I mean, it's not a different tricoloring if you just use different colors, right?
Well, let's say because maybe that's why it's easier sometimes to think of the number. We're just sort of always using the same 3 things, like 0, 1, or 2, or let's say red, blue, and white. So is your question, you didn't want to use red, blue, and white, but like purple, magenta, and...
But I mean, it's still the same tricoloring, right? Or even if you switched where the blue is to a different spot.
Oh, okay,
right?
so you want to switch the blue to, say, here.
Right. It's still the same.
No, it's not the same.
Well, why?
You said switch the blue over here. Switch the blue over here made it different.
But I mean, it's still a tricoloring.
Right, but a tricoloring is a particular kind of labeling, and I labeled it different.
All right, but it's still the same thing.
Yeah.
This is a different name for
You're
it.
thinking too hard. It's kind of like, okay, the point is it's different because it looks different. So let's call right. So you can do this. So actually, this is part of your last problem, right? Like when you have a tri-coloring, what's a simple kind of thing you can do? As Luke doesn't want to count them, but I suggest you count them. You can sort of switch all the colors. You can switch red and blue, and get a different color, right? Because actually, if you think about it, if at least 2 colors are used, right? And then with the other condition, it turns out you have to use all 3 colors. So it's kind of, but the reason it's kind of phrased this way is in the problem about 5 coloring, which is on the homework, it gets a little bit more subtle. So anyways, here's a different coloring. I guess, actually I don't want to, I know the answer, so I don't want to go through all of it. You can see there's more. Here I moved the blue here, but I left the red. So I switched the blue and the white. I could have switched, what, the blue and the red, right? And gotten different coloring, right? So how many, maybe you guys already know, how many colorings are there of this one picture?
6.
6, Otter says. Right? How many, it's basically you can think of it as there's 3 strands. So there's sort of three things you want to color. Each thing can get 1 of 3 colors. And the way this diagram is, right, so there's one coloring where you had to use a different color for each one of these 3 things. So if you went like red and blue, then the last one, because of the way this picture is, had to be white, and then, so this is all due to the tricoloring condition. Then, like, how do you sort of reorder the colors for these 3 things, right? And if you think about it, it turns out there's 6, right? Because you can only use, you can't color 2 of the strands like blue, and then a third one like red or something. So that rules out some possibilities.
What if like you change the formation of it? Like if you flip it upside down, is that a different tricoloring?
if you flip it upside, like you turn it,
Yeah, like I picture like you just turn over like the flip.
right, but I guess when you turn it, I would still consider that the same,
Because you can
picture.
rearrange it into looking like.
right, because there's planar isotropy that kind of turns it, so that's the same. Okay. All right, anyways, what's another one that's kind of maybe a more illustrative example here? So here's you can still tell it's a trefoil knot, but it's a different diagram, or different projection. Okay? How do you try to color this? Actually, is it even tricolorable? Just because it's the same knot doesn't mean like this, because we tricolor this, we can tricolor this. Like maybe it's not automatic, you have to try to do it. Someone raise their hand. Deepak?
Probably no, because it has 4 strands.
Yeah, but the 3 unfortunately is sort of coincidental here. Well, it turned out to be on the homework. Before I answer your question, on the homework, the last example asked you to sort of construct a bunch of pictures that have more than 3 strands, and they're all supposed to be tricolorable.
It's still tricolorable because like the weird loopy thingy, if you color one color of them, it's just like one intersection.
The weird loopy thingy.
Yeah.
Let's just call it the not weird loop, because it's a pretty easy loop. But see this, let's just take one of the colors like blue here. Blue here, and then what was that? That was like white, and then maybe I should have picked the second one, but here we go. Here's that, and then here it was original colored white. It's like, oh, what do we do now? Well, let's just whatever this one was, let's just make this whole thing the same color, which is white. Is that a tricoloring? Is this thing loop?
And that works too because you could just like if you could grab that little loop on the right and just like turn it like this, it would be the same exact thing.
No, that's a different.
But it is
It's tricolor because
Jesse?
at every
Take one.
intersection there's 3 different colors, and at that intersection they're all the same.
Right. So.
No, but I'm saying that's why it's able to be tricolorable.
It's a
Like,
type
that's
Oh,
why-
so you're thinking ahead.
Here's the type
I
one.
think what Luke's saying is, someone's even pointing out he's read the textbook. Good. But Luke's saying anytime you take a tricolorable diagram and add a little kind of simple loop, not a weird loop, just a kind of normal loop, you can still keep the same, the thing that you put the twist in, you can just keep that color and it should still work. But we'll go over that in just a bit. But if you look here, you should see it's a tricoloring. There's at least, 2 colors used. These things should still have the same condition hold of either all or one, because it held before. And here, it's all one color. So here's an example where we had to use all one color at a crossing. Someone, is your name Sam?
Yeah. Wait, why, again, is that like an exception? Like why can there only be one color at that crossing?
Oh, actually, right. So first off, we all agree, I hope, or Sam agrees that this is a tricolor.
Yes.
Right? And then I think what Sam's trying to get at is there a way to tricolor this picture another way, though, where at this crossing you had 3 colors?
Yeah.
But no, because look, this thing, whatever you color this is actually connected up to that. So these 2 have to be the same.
Right.
But if they're the same, then this has to be the same by the tricoloring condition. So it turns out this crossing is going to always just have one color if you tricolor. So this turns out to be, the loopy thing is kind of a funny situation here where you're sort of forced to use one color. Okay, so regarding the strand question, and I drew a picture sort of like this before, and since we haven't read 1.2, probably not everyone has because it's not assigned, but you might wonder what the connected sum is for the last problem. So let me explain what you're supposed to do for the last homework problem. For the last homework problem, I would suggest just take the regular picture of the trefoil like this, and by connected sum of say 2 trefoils, what I just mean is take two pictures of the trefoil, then do this. Okay. So this is now, so this is the connected